So if we think about the global challenges that exist, one of those is clearly energy supply. And one thing that we all want to see is a low carbon supply of energy. We've got 4 billion square metres of roofing in the UK that are doing not much more than keeping the wind and the rain out. And what we want to do is try and create that link between the small-scale solar energy, fantastic research that's being done in the UK on producing very highly efficient solar cells, and this huge amount of space that's available on buildings. So we in specific want to connect up the two. We want to develop the pathway from small-scale devices right through to large-scale integration into buildings. And to do that, we need to try and address the energy challenges that exist at the moment. So Specific, with its network of different projects, can do that. And PV, along with the work that we're doing on thermochemical storage and batteries, is part of that story. What we've been able to do is bring together lots of different people from lots of different locations, bring them to Swansea, bring them to the great facilities that we've got here, and have them tackle some of the most important scientific challenges that exists in photovoltaics and solar energy research. In particular, with the focus on how do we get some of these really cool technologies, some of these really cool inventions, how do we get them onto a building? How do we take it all the way from the lab right through to integration into a building? And that's a really good challenge to have people work on. And we've been doing that now for a while, and we're starting to make some really important breakthroughs in this area. So we've been working on a number of different solar energy technologies for a while. For example, dye-sensitized solar cell. And we've been trialling them on buildings, and they work very well, but they weren't quite making it in terms of their lifetime. And so we were looking for alternatives. And through some great efforts elsewhere, perovskite technology came onto the scene, and it was an ideal technology for us to work on. So we started working in the early days, and we've been looking at those engineering challenges for perovskites in collaboration with some fantastic physicists and some fantastic chemists in the UK and abroad. And what we're able to do is bring the engineering dimension to these technologies and look at what is required to go from small-scale glove box fundamental research challenges and take them right through into large area devices. And there exists this gap between the two, and we've attempted to try and fill that gap. It's a privilege that we get to work not only with some great people in Swansea, but we also get to work with some great institutions in the UK and abroad. And we've got a great feed through of new chemistries, of new materials, of new devices. And what we can push out then is integration of these at scale onto buildings. So it really is a fantastic scientific and engineering marriage. Well, I think one of the key challenges is that a lot of this was new. Perovskites were new in 2000, relatively new in 2013 and 14. And those engineering challenges, those methods by which we can get small devices onto buildings, they didn't exist yet. And so there was this open landscape in front of us for us to challenge and to occupy and to research. That is an incredibly exciting thing for a scientist, to have this opportunity in front of you. And so during that period then, we've tried lots of different things. Some of them worked, some of them didn't. And we're now at that point where we can create modules. We can take something which only existed at very small scale a few years ago, and we can actually make large area modules that can be put onto buildings. And it is an absolutely exciting thing to be able to have made that contribution and have made it through Specific and the people that made up Specific. So we've taken an interesting approach in Specific, mainly because we can't make our mind up. There's so much opportunity in roll-to-roll, flexible perovskites, and there's so much opportunity in glass-mounted perovskite modules. And so we've decided to take a parallel approach. So we develop the roll-to-roll processes that are required on flexible substrates that maybe require low temperature, but we also work on large area glass modules that are more rigid and perhaps can be better sealed with greater glass-based encapsulation. Generally different challenges, but the core material that we use, organic photovoltaics or perovskite material, is the same. And so we bring two sides of the technology at the same time. And that, I think, is probably relatively unique for Specific, that we work on flexible roll-to-roll and we work on rigid, printable glass modules as well at the same time. In terms of what's helped us to get there, well, we've been fortunate enough to remember one important thing, and that is to not reinvent the wheel. We have been fortunate enough to work with some fantastic scientists in the UK that have helped us to progress the technology. So one of the things that we don't do is that we don't work in isolation. We work with people who understand the fundamentals of the device, and we work with people who understand the integration of the technology into buildings. And we sit really nicely in the middle. So the support that we've had has been fantastic, particularly in the UK from industrial partners and academic partners. We've had a feed-in of fantastic research, and we've had an industrial and commercial pull. And so we've sat in the middle and worked with both of these different partners, and it's been an absolute privilege. And we're now starting to make that bridge to getting these fantastic technologies into buildings and understanding what the challenges are of integrating small area devices into large area usable products. So the last 10 years has brought us to a point where we can make modules. We can make things that people can use. We can make devices that can power things, but there's still a journey to go. These devices still need to be made to last longer. They still need to be integrated into buildings. They still need to be made at scale. The dream is still millions of square meters of solar energy material. That is still the dream, and there's still a fair bit of research left for us to get there. But that's what we want to see. And we want to use active buildings, and we want to use a whole mix of technology to bring that to the market. And so the role that we play as scientific and engineering links between the fundamental and the integration is going to be required for some time yet. But I think the dream over the next 10 years is to really see these materials and modules put to use and to understand, what are the next set of challenges. And one of the things that we're fortunate to have in Specific is some great scientists and engineers. So one of the things that I think makes Specific and its research into perovskites special is the people. So there can be a pull, there can be a commercial pull, there can be a push, or there can be a demand from industry. But if the team, if the undergraduates, the postgraduates, the postdocs, and the academic team don't have the ideas, then nothing happens. So a lot of the success that we've had has been built on the ideas of the research team. And so we're very fortunate to have a constant flow of good ideas coming through from our team that push us from that lab scale to that factory scale. So the key to any successful organization is not just the people, but the support network that exists around those people. So we're incredibly fortunate to have the support of a wonderful university in a wonderful city. Swansea University has and is the birthplace of Specific and its location. This university has always been there for us in terms of the growth and development of Specific, and we're absolutely delighted to be part of Swansea University. The other part of a successful organisation is to be backed by funding organisations. For somebody to share the dream and share the belief that you want to make a difference. And we've been incredibly lucky to have support from EPSRC, from Newton, from Royal Society, from the Welsh Government, from the UK Government, and from the European Union in order to deliver on the shared dream that we all have. We have been supported and we have been backed to deliver. On the other side then, we need to be honest to what we want to achieve, and to do that we need to have industrial people come and guide us in what really can be made and what can be sold. And we're absolutely privileged to have some of our core partners in terms of NSG and Tata Steel to guide us in that journey from lab scale to factory scale. So in the mix of the success that we've seen over the last 10 years has been this group of funders, industrial partners, and universities that have shared the dream and backed us, and we couldn't have done it without them.